Hey, how's it going? Today I'm going to talk to you a little bit about research design and what that means. So my name's Tyler Black, and I'm a junior at Westminster College, and I'm a psychology major slash ski bum. We're based out in Salt Lake City, Utah, and it's a pretty awesome school. We like to have a lot of fun and learn a lot of cool stuff, so feel free to check us out at westminstercollege.edu. You may be asking yourself, what is this research design he keeps talking about? What does that mean? Research design is, in general, a way of logically conducting research that the psychology community has come upon to agree is the best way of conducting research and presenting research, and allows us all to have the same sort of framework when doing experiments. Why is your study worthwhile? What are the results going to mean? What might they do? Who might they impact? Essentially, why are you doing this study? You can think of framework as a sort of frame that supports your experiment and why you're doing it. This can be theories, beliefs, and prior research that back up, guide, or inform your studies. Up next is your research question. This is very important. What are you asking? What do you want to get to know better? What relationships are you looking for? And what questions capture what you want to know? Next is methods. How are we going to actually conduct this study? And what approaches or techniques will you use in order to make this study happening? This means that you are looking for how you're going to collect your data, who you're going to collect your data from, and how you might go about analyzing and presenting your data. Finally, we have validity. When we think about validity, we want to make sure that our experiment proves itself and proves itself to other people. Why should other people believe your results, and why is that important to them? You should also think about what other possible outcomes there are, and if someone were to copy your experiment, would it go the same way or might it go differently? Today we're going to talk about two different aspects of research design: correlational studies and experimental studies. Correlational study allows us to observe our surroundings and the variables around us and identify possible relationships between the two. When we do a correlational study, we must identify our certain variables that we would like to study, and we would like to identify what possible relationship or what relationship we're looking for between the variables. It is very important to note that correlational studies can only predict a relationship. Correlational studies cannot prove anything since we are not in a controlled environment and we are just observing. An example of a correlational study would be, do women stop at stop signs more or men stop at stop signs more? To do this study, we might go out to a specific stop sign in our area and sit and watch and take note of who stops at the stop sign and who doesn't. We can then analyze that data to figure out our results. An experimental study differs from a correlational study because in an experimental study, we have a controlled environment where we are in control of what is happening. It is very important that when you manipulate your independent variable, you only manipulate one variable at a time. If you manipulate more than one variable at a time, you would not know which variable is causing the effect and which is not. Using an experimental study, we can establish a cause and effect relationship between certain variables. An example of an experimental study would be looking at whether studying with a dog around causes a student to have better test scores. In this study, we can take a large sample of students and randomly divide them into two groups. One group would then study a certain amount of material with dogs present, and the other group would study the same amount of material but with no dogs present. Both groups would then take the same test, and we would observe the results and see what happens. An independent variable is changed or controlled or manipulated in some sort of way by the scientist. And we look at what are the effects that this manipulated variable has on the dependent variable. Now, the dependent variable is what is being tested. We measure how the dependent variable changes based on how we change the independent variable. So we change the independent variable and observe how it affects the dependent variable. Something that is very important to note is that our hypotheses and what they explain change based on whether we're doing an experimental study or a correlational study. In an experimental study, we can use that to imply causation and observe variables in a controlled and malleable environment. So an example of an experimental hypothesis would be students who listen to very loud heavy metal music while studying will perform poorly compared to those who study in silence. We would do that study similar to the one with the dogs, where we bring in a group of students, randomly split them up. One would listen to heavy metal music and the other would not, and then they would take the same test and see who performed better. Now in a correlational study, we can use that to observe naturally occurring variables or variables that may be unethical or impractical. An example of a correlational study hypothesis would be that smoking cigarettes daily can lead to lung cancer. Now this would be a correlational study because we could not ethically force half of a group of people to smoke cigarettes until they got lung cancer. However, we could observe those who do choose to smoke cigarettes and see whether or not they have a higher risk of lung cancer. Now something that's very important to watch out for is confounding variables. These are variables that we fail to control or eliminate during the beginning part of our study. Confounding variables can cause poor or inaccurate results, thus ruining the validity of our experiment and possibly skewing the results entirely. Thankfully, confounding variables are relatively easy to avoid if we think ahead about what could possibly cause change during our study, have a control group, and use randomization. If you look at the example below, it seems that Florida may cause Alzheimer's because there is such a high amount of people with Alzheimer's in Florida. However, that is clearly not the case because that would be ridiculous. There are just lots of old people who move to Florida, and old people tend to develop Alzheimer's much more often than younger people. So, the confounding variable in this would be old people. Florida doesn't cause Alzheimer's. There's just a lot of old people in Florida who have Alzheimer's. Now, thank you all so much for listening to my presentation. I hope you learned a lot about research design, and will keep it in mind while doing future research. Can't wait to see you in the field.